Okay, so now we're doing topography. This is one that is on every single region, so paying attention and understanding, asking questions if you don't understand something is very, very important. All right, so the first part of topography is this word fields, and we're going to be seeing this a lot throughout the whole entire course. What is a field? A field is a region in which shares the same value, whether it's temperature, elevation, air pressure, lightning bolts, car accidents, anything. That is a field. And with these fields, we then create an ISO line. An ISO line is a line on a field map that connects places having the same field quality value. So what I mean by that is the field values. They don't go 1, 2, 3, 4, 5, and you connect the dots. No, it's not like that. What it's talking about is, say for instance, temperature. There's 60 degrees here, 60 degrees here, 60 degrees here, 60 degrees here. You connect all the 60 degrees together. You don't do the count by numbers and going up like that. You have to do the same number. So there's some basic rules to isolines. First, connect all points of equal value. They have to be the same number. They are drawn at regular intervals. So you could have an interval every 10. Usually every 50, you'll see that one. You could have every 100. Sometimes you'll see every degree when it's temperatures, but it'll tell you how many, what's the difference in between or what numbers you should look for. They're always closed loops. So they're like really weird, squiggly circles. And it could take up a circle that goes all the way around the world or a little tiny circle that encompasses all of Syracuse, New York. It just depends on what field value you are looking at. However, if the line keeps going, if there are numbers that keep going off your map, these lines, these ISO lines, will go off the map and making an invisible, very weird looking circle. And they never cross. For instance, you can't have a 60 and a 50 crossing like this, because that means in one area you're both at 60 and 50 degrees at the same time. That is not possible. So they never ever cross. They're kind of like parallels. Isolines that are close together show a rapid change. The farther apart, the gradual change. And we're going to see this when we do one of the labs. The closer they are together, the faster it goes up, the faster the change. The farther apart, the gradual, the slower. Values inside a clothesline are either higher or lower than those outside the clothesline. It just depends on which way you are looking, if it's going to be higher or lower than that line that you've already made. All right, so this is what I was talking about when you see a bunch of numbers together. This diagram shows an elevation field map. So the field that I'm looking at is elevation above sea level. Complete this field map by drawing the elevation lines for 40, 50, 60, and 80 feet. You notice the elevations you need, right? It's in 10-degree intervals. So 60 is already done for you, where you find all the 60s and you are marking them and then connecting the dots. All right, so I'm going to start with 40. 40s are all over here, or sorry, 50s. 50s are all over here, and I did my best. You can do better on yours. Draw them in, and then we're going to draw the 40 right on the side, and you'll see how it goes off the map. How, as I said, one of the rules is either they're very weird closed circles or they go off the map. Like this one would go off the map, and I assume it would go around in a circle like that. Now I have my 60s all connected. Now my 70s, and you'll notice right here there's no 70. I have to infer that there's a 70, so I would put a dot right there, say here's my 70, and then connect right there. And my 80s, I would connect all like that. All right, now that I have them all done, What is the approximate elevation of point A? So A, remember one of the rules, it's either higher or lower than, the numbers in between are higher or lower. Well, here's 80, so it's got to be lower than 80. Here's 70, higher than 70. So it's anywhere between those, 71 to 79. How about B? B, again, in between 50 and 40, so anywhere between 41 and 49. And C, anywhere between 51 and 59. All right. So these isolines that we just drew, they have a certain what is it? They're called something specific. I can't think of the word at the moment. But because it shows elevation, it's special word, the word that means, hey, we're looking at isolines that have to deal with elevation. These are called contour lines. So yes, they are isolines, but more specifically, they're contour lines. So if I was to say draw contour lines, you're like, oh, Ms. Coe's talking about drawing elevation. If I was to switch these numbers for air pressure, my air pressure would be called isobars. And now right here, we have weather data plotted for January morning. Looking at these, I see degrees Celsius. These are all temperatures. That's the measurable property on this map, the field value for this map. Based on this property, the ISO lines, these are called isotherms because I'm dealing with temperature, thermometer, therms. Isobars will make sense because it's measured in millibars. So isobars, in this case, we have isotherms. Contour lines are like the different one. It's elevation. That's all you have to know. What is the approximate measurement of property for this in New York State? So New York State's right about here. I'm going to follow this line, about 5 degrees Celsius. All right. This one shows the thunderstorms, the average yearly thunderstorms. Like I said, this is a field value. Does it have a special term? Nope. It's just the average yearly thunderstorms. So approximately how many thunderstorms occur near Albany, New York? Right about there. Looks in between 20 and 30. So anywhere between 20 and 30, I would say 21 to 29 thunderstorms. Los Angeles is somewhere over here. Here's my 10. I don't see my 5 or my 0. So anywhere between 0 and 10. So 1 to 9. Less than 10. New Orleans, Louisiana. Louisiana is right around here. That's going to be anywhere between 71 to 80. Because there's your 80, there's your 70. It's somewhere around here. That's what it should be. All right, so looking at this, what is this? Okay, so this is the overhead view. This is actually called a topography map. What does that map have in common with this map? Can you see? This is just the overhead view, as if I was looking straight down at it, like just straight down. And then if I was looking at the side, this is what it would look like. So a landscape is like this, and on paper, it looks like this. This is a topographic map. A topographic map is a map that shows the height above sea level or the elevations of the land. So if you were to plot this out, you could or should get something that looks very similar to this. So elevation. It's just the distance but above sea level. And you can see this 3,047 feet, 3,998 feet, 2,186 feet. So if the sea level went up to 3,500 feet, this is what our island would look like. And these lines indicate the different elevations at 0, 500, 1,000, 1,500, 2,000, 2,500, and 3,000, 3,500. Every 500 feet. Contour line. These are on isolines on a map that connects places having the same height above sea level, the same elevation, the same number. A contour interval. What is a contour interval? These are the differences in elevation between two neighboring contour lines, like this one and this one. So if I have these numbers, I can determine, the different numbers. This would be like this is the base. I'd have to figure out what these are. So I'd go 1, 2, 3, 4, 5, 500. 500 divided by 5 is 100. Each of those lines would be 100. So that'd be 0, 100, 200, 300, 400, 500. Whereas we have something called an index contour line. Contour interval, the difference between the two. Contour index contour line, that would be those dark contour lines, usually marked with a numerical value, and you can determine the interval based off of that. If you ever see hatches, know that hatches just mean that there's a depression. Instead of going up like a peak, it actually starts to go down, right? So this could be like a pond or something. It went down a little bit. And then every so often, drilled into bedrock, you'll see something like this. This is called a benchmark. They're little plates that state the exact elevation at that point in your immediate vicinity, and it's above sea level. Spot elevations, that would be where you're looking at right there. These are found at intersections like hilltops, lakes, surfaces, and other points of interest. Okay, and the last little bit about this is the rules of V. This is very, very important. You need to know this. This will be on your regents and test. So these are contour lines that bend upstream when they cross a stream or river. Upstream, that means the point of origin. So when this happens, and you'll notice there's a V wherever the stream crosses. It looks like a V like a pointer. It can be used to determine the direction the stream is flowing. So whichever way it is pointing, it's the opposite which way it's flowing. So it points to the origin, and then the open area shows where it's going. The V points upstream. I can't stress that enough. It points upstream, not which way it's flowing. It points upstream. And the upstream is where the water is coming from. All right, so that is it for right now. If you have any questions, please don't hesitate to ask, especially on this topic. And beyond that, I hope you guys have a great day.